In this video, we'll talk about interval notation, which is a common thing that we will use to describe certain sets of real numbers, and particularly use it a lot to talk about where, meaning in what real numbers, functions have certain properties. So we use these open parentheses a, b, to denote the set of all real numbers between a and b, so those numbers that are bigger than a and those that are less than b. So we will need x to be strictly bigger than a, and x to be strictly less than b. So these here are strict inequalities, as in a, the number a, is not in this set, and neither is b. Now if a is bigger than b, then there's no real numbers in this set, so this set is empty, or means there's no real numbers, nothing in it. And that's fine, it's not really useful, but it's fine. Now what if I want to include the endpoints? Well, if I want to include the endpoints here, I will use a closed bracket, so a square bracket instead of a parentheses at that endpoint. So a square bracket means the endpoint is included, where the open of the parentheses means it's not. So for some examples, if I look at the interval from 1 to 3, where the 1 is closed and the 3 is open, this means that, for instance, 1 is in this set, so is the square root of 2, but 3 is not, and 5 is not. But remember, intervals that we're talking about in this class are sets of real numbers. So set is not just 1, 2, and 3 is not in it. It's all real numbers between 1 and 3, which includes things like the square root of 2. For example, e, which is like 2.718, is also in this set. We can also think about these in terms of pictures. So for instance, I can draw a number line here. And if you look at the interval from 1 to 3, what that should be is, say I have 1 here, I have 3 here. I want to include 1 but not include 3, so I will have a full circle here at 1, and the line going through here to an open circle at 3, which indicates that 1 is in the set because it's filled in, and 3 is not. A related concept to that is that of absolute values. So absolute value of x as itself is a pretty simple function. So the absolute value function is just defined to be x if x is positive, and negative x if x is negative. In a sense, it always gives you the positive version of the number, but it does that by flipping the sign if that number is negative. And how does this relate to absolute values? Well, for instance, I can look at an absolute value inequality. So something like x minus 1 is less than 3. And I can figure what that means in terms of an interval. So I can do that as first by splitting this up by sort of undoing the absolute value part. So if the absolute value of x minus 1 is less than 3, what that means is that negative 3 is less than x minus 1 is less than 3. Because if absolute value is smaller than some number, that's an inside thing, and it means that I must be less than these two outer bounds of minus 3 and plus 3. Then I can solve this out by adding 1 to each side. Minus 2 is less than x is less than 4. But now that's an interval. That is the interval minus 2 to 4 with both open parentheses. And we could also go backwards here. I could take this interval and work backwards to here. And that involves finding the midpoint of the interval, which is going to be this number in here. This will be the midpoint. And this will be the radius. So in this case, the midpoint here would be 4 plus negative 2 over 2, which is 1. And the radius is the difference divided by 2. 4 minus negative 2 over 2, which is 6 over 2, or 3. That will give me those two parts to get me to the absolute value relationship there. Now, what about the other way? If I had something like x minus 2 is bigger than 1, where does that get me? Well, now in this case, I have to split this into two different inequalities, because if you think about the graph, if an absolute value is bigger than a number, that gets me two separate regions of this answer. So if I draw a graph, x minus 2 is going to look something like this. And it being bigger than 1 means I want to be above that line. There's two segments here. There's the one on top, and then the one below to the left. So we're going to get two separate inequalities that have to be satisfied here. So I either want x minus 2 bigger than 1, which means x is bigger than 3, or I want x minus 2 less than negative 1, that's the other half of the absolute value, or x is less than 1. Now each of these can be written as intervals on their own right. So the orange one is just 3 to infinity, and the purple one is minus infinity up to 1. And I could leave those as a list, or I could put them together with what's called a union sign, which is like a little U you put in between them. And that means I sort of am taking these two sets and putting them together to make my new answer. So it's 3 to infinity union minus infinity to 1, because if I put those two sets together in the sense that I just kind of take them all at once, that's the actual answer to where is x minus 3 value bigger than 1.